Hello everyone, welcome to Leetcode Biweekly Contest 74. As always, I'll be going through the solutions at the end, so stick around for that. Hopefully, I'll do well again this time. I've been doing quite well recently, so hopefully that doesn't change. I'd probably just jinx myself, we'll see. I accept it. How many times is a subsequence? Okay. So. I'm just going to do prefix, suffix stuff. I'm pretty sure I'm doing this in a not smart way, but oh well. I'm not sure what the smart way to do this is. Alright. 4, 6. I guess there's some off by 1 somewhere. what should that be? That should be 5. I wonder what I'm doing wrong. MP. Okay, I'm being bad. How about that? Alright, that was dumb. Okay, I'm worried about precision errors. We can just throw this into priority queue. I know we can do that, but yeah. Okay, it didn't. Please don't alien me. That's 4. So if the position starts at 0, return 0. If white is 1, what is that convention? 96 max res. Should be min. Don't TLN me, please. Okay, that got AC. I'm resubmitting in C++ because I do not trust Leetcode. It should be fine, but that was disappointing to have the penalty, because otherwise it would have been an okay time. Unfortunately, with the penalty, that's probably not going to be very good. Yeah, that's just not a good solve for me. I'm gonna pray that the other one's good enough. Alright, I'm just submitting in C++ because I'm scared of TLE. That's the risk you take as a Python user, I guess. Index -1 out of bounds. That should be if x is less than 0. 2, 0. Alright, I got AC. So I submitted the C++ as a backup just in case the other one TLEs. Now, it says I'm second, but my penalty is still bad, so that's going to go up. Anyway, I'll go through the solutions pretty quickly. Hopefully this doesn't destroy my rating too bad. Okay, this one, basically, we observe that for each particular element, we need that element to occur an even number of times. So what I can do is, I can just generate I can generate a frequency dictionary or map such that now I know for each distinct element in nums, how many times does it occur. Then I take all of its occurrence values and check if they're even. And if they're all even, then the answer is yes, otherwise it's no. It's pretty simple, actually. N is less than or equal to 500, so technically we can just loop over each element and then use dot count. So we can loop over each element in nums, and then for that number we can just iterate over nums to find the frequency and check if that's even as well. That algorithm would be an O(n) squared, but if I use a frequency dictionary, that will be an O(n) time. This one's just me being stupid. Okay, so this one's actually pretty embarrassing. Let's just say, let's say the pattern is P equals AB, and then here our text, let's just say text is that. Maybe it's like that. And let's say I'm going to add in a B. Now, where should I put in this B to maximize the number of sequences? As it turns out, the best place to put this B is we always want to put that B at the end. The reason why we put this B at the end is because this B will match up with the most number of A's, so we're increasing the total number of so basically the number of sequences in the new text is just the number of sequences of the old text plus the number of sequences which involve this B. So if we just want to maximize the number of sequences involving this B, I should put that B at the end. And similarly, if I was going to add in an A, I should put the A in at the start. So all I do here is first I find first I'm finding the number of sequences, subsequences of text which have the pattern, and then either I'm adding in either I add into the A, and then if I add in the A, then the number of sequences will increase by the number of times B occurs. And alternatively, if I chose to add in the B, then the number of sequences would increase by the number of times that A occurs. So that's why I'm just taking the max. And then how do I find the number of sequences? Well, I just have these two variables A and B, very confusingly named, but I was just in a rush. At any point as I iterate through text, the variable A will store the number of times that I've seen the first letter of P so far. So in my example, this variable A references in my current prefix how many times have I seen an A, and then when I get to a B, I increase that B by the number of times I've seen an A before, because that will be when I come across a B, I want to find the number of sequences that end with this B, and that number of sequences is simply the number of A's I've seen so far, and that's how I find the number of sequences. I handled this as a separate case. When P contains only one letter, then it doesn't matter. It doesn't matter where I put this element in. If I add an A into text, then the number of A's will be the original number of times that appeared plus 1, and then I'm just looking for how many like pairs can I make from those S characters, and that's just S choose 2. Let's take a look. Yeah, that's not good. Oh, Larry's also making a bug in this one. This one, basically, I'm just doing a greedy algorithm. I'm going to keep taking the largest number in nums, and then I'm going to half that one. And the key observation is that we're not going to take more than n steps, because what I could do is I could simply just take all n elements and half them. And so what I could do is I can choose each of these elements to perform one operation, and that would halve the total sum, which means that the number of operations I'm taking is not going to be more than n, which means that when I do my priority queue thing, I simply take the largest number from the priority queue, half that, and I'm going to keep going while the sum is, while I'm not done yet. And since this loop is only going to loop at most n times, the runtime is n log n. And then finally, we have this question where DP adds, so the DP state is, I can solve this DP. The DP state is which position I am up. So I'm only going to consider some prefix of floor. So I'm going to say out of all the tiles with a position less than or equal to pos, and if I have number of carpets remaining, then what's the minimum number of white tiles I can end up with? There's two cases. So for my let's say my current prefix is these 3 ones, and then, or maybe these 4 ones. So let's make it these 4 ones is my current prefix. And let's say carpet length is 2. Then the two cases is either I can have the carpet at the very far right. If I have the carpet at the very far right, then the number of ones is simply the DP of the prefix bit what I haven't considered yet. So the prefix which is not covered by my current carpet, but I have one less carpet available. And I can only do this if I still have a carpet left over. Otherwise, I don't have carpet in the very most right. And then in that case, the number of white tiles I have remaining is simply the number of white tiles in from the previous position, plus 1 if my current position was white. And that's my DP state. Posits and carpets are both up to 1000, so this has at most 1 million states, and the transition time is 01. So the overall complexity is just O, the length of the floor times the number of carpets. And yeah, that's basically it. Thanks for watching, and I'll see you guys next time.